Welcome dear students, welcome back to our today's online class. We are studying about hydrocarbons and their types. Let us quickly revise what we have learned in our previous class. So there are three types of hydrocarbons. They are alkenes with general formula CnH2n plus 2. They are also called saturated hydrocarbons and they are all single bonded compounds. Second type of hydrocarbons are alkenes having general formula CnH2n, and they are unsaturated hydrocarbons as there exists double bond between two carbon atoms. And the third one is alkynes having general formula CnH2n minus 2. They are also called unsaturated hydrocarbons as they contain triple bond between two carbon atoms. Now let us again check our reduced syllabus. Now today we are going to study about alkenes double bonded hydrocarbons and alkynes triple bonded hydrocarbons, and we will see their main properties, particularly addition products with hydrogen, which is also called hydrogenation, and halogens, namely chlorine, bromine and iodine. And this particular reaction is called halogenation. Addition of hydrogen is called hydration and hydrogenation, and the addition of halogens are called halogenation. Alkenes. Alkenes have general formula CnH2n, two hydrogens less than alkanes. Alkenes are also called olefins or oil-forming compounds, as the lower members of alkenes form oily products when they are treated with chlorine or bromine, and hence they are also called olefins. They are unsaturated hydrocarbons having double bond between two carbon atoms. So this is the general structure of alkenes, where there is a double bond between two carbon atom, and the rest valencies are satisfied by single bond connecting to any other atom or group of atoms. Now let us see some homologous series of alkenes. The first compound of alkene starts with two carbon atoms. Therefore, it is an eth. The root word will be eth. So the molecular formula of first compound of alkene is C2H24, which is ethene. The condensed formula is shown like this with double bond between two carbon atoms. This is the structural formula where there is a double bond between two carbon atom, and the rest valency, that is two valency of each carbon, is satisfied by single bond connected to two hydrogen atoms on both carbon atoms. The common name of ethene is also ethylene, and ethene is IUPAC name. Second homologous compound series of alkene is with three carbon atom, therefore it is prop. So it is propene, this is the condensed formula having double bond between two carbon atom. This double bond can be with this and this carbon also. It can be anywhere, but there has to be a double bond. This is the structural formula, and this propene is also commonly known as propylene. In the same way, as the number of carbon atom increases, their name also changes. The next compound in the homologous series of alkene is butene, because there are four carbon atoms. Now in this particular reduced syllabus, you only need to study about the first compound of alkene series, that is ethene, with common name ethylene. Now let us see some details about ethene or ethylene. It has the formula C2H4, which we can get from the general formula C2H2n. This is the structural formula of ethene, where there are two carbon atoms bonded by double bond. This is a double bond between two carbon atoms, and the rest valencies are satisfied by bonding with hydrogen atom with a single covalent bond. Now, ethene is a colorless and inflammable gas with a faint sweetish smell. It is sparingly soluble in water but highly soluble in organic solvents like alcohol, ether, and chloroform. It is used in making polythene, the polythene which we use to carry different items in our everyday life. It is also used in ripening of fruits, and it is used in making epoxyethane, which is used in the manufacture of detergents. So ethene also plays very important role in manufacturing detergents. It is reactive due to the presence of double bond. So this double bond is a weak bond. It breaks easily and hence reacts with other atom or group of atoms. Hence the reactivity of ethene or alkene is more than alkanes. It undergoes addition reaction, whereas alkanes, we have studied that alkanes undergo substitution reaction. Now let us see the third type of hydrocarbons, and they are alkynes. Alkynes have general formula CnH2n-2. They are unsaturated hydrocarbons having triple bonds between two carbon atoms. And this way, so between two carbon atoms there are three covalent bonds, and these three covalent bonds together are called triple bond. So the valency of carbon is 4. So with this 3 bond and with one extra bond this side, 4 valency of this carbon gets satisfied, and with the same triple bond and with this single bond over here, the valency of this carbon also gets satisfied. Now homologous series of alkyne, let us see. Again here, like alkenes, alkynes also starts with 2 carbon atoms. So its root word starts with eth. So the molecular formula of the first compound of alkyne series is C2H2N, and this is the condensed formula where triple bond is shown between 2 carbon atoms. This is the structural formula. Please remember, in structural formula all the bonds has to be shown, whether that be single bond or double or triple bond. Those bonds has to be shown, whereas in condensed formula we need to show only the main bonds, such as double bond between carbon atom or triple bond between carbon atom. The common name of ethine is acetylene, and IUPAC name is ethine, so which is a triple bonded hydrocarbon. Another compound is with 3 carbon atoms, so it is propine. It is propine. So this is the condensed formula, this is the structural formula where all the bonds are shown, and the common name for propine is allyline. So in the same way as the number of carbon atom increases, we get different types of alkyne compounds. But according to reduced syllabus, we only need to focus on the first compound of alkyne series, that is ethine. So let us see some basic properties of ethine first. So ethine is also called acetylene. So this is the structural formula of ethine, where between 2 carbon atoms there are 3 covalent bonds, and this 3 covalent bonds is called a triple bond, and the rest valency is satisfied by hydrogen. Acetylene is a colorless gas with ether-like smell when pure. So pure acetylene smells like ether. It is used for oxyacetylene flame for welding purpose. So all the welding shops, they use ethine and oxygen gas for the welding purpose. This is very, very important use of ethine or acetylene. and the name of the gas or flame is called oxyacetylene flame. It is a highly reactive compound due to the presence of a triple bond between carbon-carbon atoms. And in fact, alkynes are the most reactive hydrocarbons among all the hydrocarbons because they have triple bond. Due to greater carbon content than alkanes and alkenes, its all carbon do not get oxidized completely and hence burns with a shooty flame. They produce carbon. It undergoes, again, like ethene, it also undergoes addition reaction. Now let us see addition reaction. Addition reaction are those reactions in which one or more atom or atoms or group of atoms gets added to the compound by the breaking of double or triple bonds. So the reactions in which extra atom or group of atoms are added to the compound is called addition reaction. This addition reaction is usually carried out in the presence of catalysts such as platinum or palladium at ordinary temperature or nickel at 200 degrees Celsius. So it is a catalytic reaction. So addition reaction of alkene and alkynes are catalytic reaction, and the catalysts used are either platinum, palladium at ordinary temperature or nickel at 200 degrees Celsius. Now, suppose this is a double bond compound alkene, where I have only shown double bond between carbon atoms. Now, if the addition reaction is carried out, then initially what happens is, now we all know a covalent bond is formed by sharing of two electrons. One covalent bond is formed by sharing of two electrons by each atom. So over here we have two covalent bonds between carbon atom, double bond. So for this bond there are two electrons, and for the another bond there are again two electrons being shared between two carbon atoms. So when we do addition reaction and when we provide energy, that energy will break this one covalent bond. Out of the two bonds, it will break one covalent bond. And when the bond is broken, here we have two electrons. Now one electron will go to one carbon atom and another electron will go to another carbon atom. So there will be one free electron on each carbon atom, which can again form a covalent bond with any other atom. Let's see how it takes place. So it breaks. So only one single covalent bond remains between two carbon atoms, and each electron on each carbon atom can again form covalent bond with other atom or group of atoms like this. So they will finally break down into a single bonded hydrocarbon atom, alkanes. In the same way, when we do addition reaction with alkynes, a triple bonded compound. So here we have three covalent bonds between two carbon atoms. Again, when we do addition reaction with the help of energy, in the first stage, one bond out of three covalent bonds, one bond gets broken, and two bonds between two carbon atoms remains, thereby forming a possibility of forming single bond by each carbon atom on any other atom or group of atoms. Again, if we further do addition reaction, then the energy will again break one covalent bond out of these two and gives the possibility of forming a pair of single covalent bond to each of the carbon atom. Thereby, when two covalent bond breaks, we get four single covalent bond with the two carbon atoms in such a way. Thereby, the final product of addition reaction, when the addition reaction completes in alkynes, we again get alkane product. So this is how the addition reaction takes place. Now let us try to understand this by taking examples. So addition of hydrogen. When we want to add hydrogen, then that particular reaction is called hydrogenation. So let us see hydrogenation reaction of ethene. So here this is an ethene compound, C2H4, where double bond. This is a condensed formula where double bond is between two carbon atoms. So when we add hydrogen to this with the help of nickel as a catalyst at around 200 degrees Celsius, we get ethane, a single bonded hydrocarbon. Let's see the reaction mechanism. So in the beginning we have ethene like this. This is the structural formula, but double bond is between two carbon atoms. So when we bring hydrogen in the presence of catalyst nickel and at around 200 degrees Celsius, with the energy, this bond gets broken and it forms two single bonds with carbon, where carbon gets attached to one hydrogen atom, one carbon gets attached to one hydrogen atom from this hydrogen molecule, and another hydrogen atom gets attached to this carbon atom by a single covalent bond. So in this way, double bonded ethene can be converted into a single bonded hydrocarbon, ethane. This particular type of reaction is called hydrogenation. In the same way, we can carry the addition of hydrogen to ethene. So when we add hydrogen in presence of nickel as a catalyst at around 200 degrees Celsius, in the first stage, one of the three bonds gets broken and two hydrogen atom gets attached. So ethene will be converted to ethene first, because in this ethene, in this compound, there is still double bond present. Now if we carry addition of hydrogenation reaction to this ethene, then we finally get ethane, because from here double bond gets broken and again two hydrogen can be attached to the compound, so forming ethane as the final product. So ethene can be converted to ethane in one single step by hydrogenation, whereas ethine can be converted to ethane in two stages by the addition of hydrogen. Now let us see addition of halogens. And addition of halogens are called halogenation reaction. For example, ethene, when chlorine is added to ethene, then we get derivative of ethene, and that is 1,2-dichloroethane. This reaction also takes place in the same way as addition of hydrogen takes place. First, double bond gets broken and we can form two single bonds on each carbon atom which joins with chlorine atom. And the IUPAC name of this compound will be 1,2. If we take this as one carbon and this as two carbon, so it will be 1,2. How many chlorine atoms are there? 2, so dichloroethane. So let us see the reaction mechanism. So this is a double bonded compound, ethene. So when chlorine is brought closer to ethene with the help of energy, double bond gets broken and we have the possibility of making a single bond on each carbon atom, and this bond can be made by taking the help of chlorine atom on each carbon atoms. Here we get 1,2-dichloroethane. In the same way, bromine can also be added to ethene or ethine. So when bromine solution in carbon tetrachloride, this is carbon tetra, 4 chlorine, so tetrachloride. When bromine solution in carbon tetrachloride has an orange color. So bromine solution in carbon tetrachloride has orange color. It appears orange in color. But when this orange color bromine solution is added dropwise to ethene, the orange color of bromine disappears due to the formation of colorless ethylene bromide. That means double bond gets broken and bromine gets added to the ethene. Therefore, the brown color disappears because new product has been formed with new chemical properties. Let's see the reaction mechanism. So this is the reaction. When bromine is added to ethene, we get 1,2-dibromoethane, and the formation of this compound gives different chemical properties, and one of the chemical properties is colorless. Bromine is colored, orange colored, whereas this compound where bromine is attached, it is colorless. So the reaction mechanism is same. When double bond compound ethene is brought closer to bromine, with the help of energy, this bond breaks, which gives the possibility of forming two single bonds like this, and to each single bond bromine can be attached. Halogenation of ethene. Like ethene, ethine also undergoes halogenation, addition reaction of halogens. So here we get the products. But ethine undergoes complete halogenation in two stages. In the first stage, ethine reacts with chlorine to form 1,2-dichloroethene. Now here again there is double bond. So in the second stage, when chlorine is added, this double bond, one of the covalent bond breaks and forms another two covalent bonds over here on each carbon atom where chlorine atoms can be attached. So again two more chlorine gets attached to the compound, forming the final product CHCl2, CHCl2. So the name of the compound will be 1,1 because two chlorine gets attached to first carbon and two chlorine also gets attached to second carbon atom. So the name of the compound, IUPAC name, will be 1,1,2,2-tetrachloroethane. Bromine solution in carbon tetrachloride here also has orange color, and when it is added to ethine, the orange color of bromine disappears. The reason behind this is again due to the formation of colorless addition product. So this is all about ethene and ethine and their two main reactions: addition reaction, hydrogenation, addition of hydrogen, hydrogenation, and addition of halogens, halogenation, which you have to study according to new reduced syllabus. I suggest you to go through other details in your book, textbook, okay, and complete your today's assignment. This much for today, and this was our last video for our hydrocarbons. And with this, we complete our this year's syllabus. Until we meet next time, stay safe and do all things well.